Okay, so let's see the juxtaglomerular apparatus. For this, first of all, let me say this is called juxtaglomerular apparatus. To see the Raas mechanism, we need to see first of all juxtaglomerular apparatus. Okay, so let us see the juxtaglomerular apparatus. So let me introduce once again. This is the Bowman's capsule and proximal convoluted tubule, descending limb and ascending limb, and the distal convoluted tubule. Okay, so now afferent arteriole and efferent arteriole. This is the afferent arteriole and this is the glomerulus, and this is the efferent arteriole. We are making little change in the positions here. That distal convoluted tubule is going to connect with the juxtaglomerular, that afferent arteriole, to form the juxtaglomerular apparatus. Now I am showing that particular area a little bit directly in the microscope. This is the afferent arteriole and this is the glomerulus and the efferent arteriole. Now the distal convoluted tubule, this is DCT, distal convoluted tubule, and this is afferent arteriole. So this area where they come in contact each other, that they'll come in contact each other, that we need to believe, because all the time when we see the positions like this, that this kind of contact is impossible, isn't it? So but the distal convoluted tubule actually will come in contact with the afferent arteriole. So that connection, this connection, little bit in zoom I am showing here, that this connection, the connection between the distal convoluted tubule as well as afferent arteriole is said to be juxtaglomerular apparatus. Let's discuss that particularly. That we know the afferent arteriole means that is having tunica externa, media and interna. Distal convoluted tubule, that is lined with simple cuboidal epithelium. The distal convoluted tubule is with simple cuboidal epithelium. The simple cuboidal epithelial cells which are densely arranged in that the DCT are called as macula densa. They are called as macula densa. Okay. Next, the smooth muscles of the afferent arteriole are called as juxtaglomerular cells. The smooth muscles are called as juxtaglomerular cells. The smooth muscles of afferent arteriole. So let me write here. This is the smooth muscles of afferent arteriole. This is the cuboidal epithelial cells of DCT. Cuboidal epithelial cells of DCT are called as macula densa. Okay, so then let me put heading here. This is DCT, distal convoluted tubule, and this is afferent arteriole. So afferent arteriole, what is the participation from the afferent arteriole? The smooth muscles of afferent arteriole are called as juxtaglomerular cells. The cuboidal epithelial cells which are densely arranged from the distal convoluted tubule is called as macula densa. Juxtaglomerular cells of the smooth muscles of the afferent arteriole. The cuboidal epithelial densely arranged cells of the distal convoluted tubule are going to form juxtaglomerular apparatus. We use it to say it as JG apparatus or juxtaglomerular apparatus. When we go for the text lines, we'll have some complexity. The complexity on the screen, let me say here. The juxtaglomerular apparatus include the juxtaglomerular cells, which are the modified smooth muscles of the afferent arteriole, and the densely packed arranged cells of the cuboidal epithelial cells of the distal convoluted tubule, wherein come in contact with the afferent arteriole. Likewise, these kind of statements will come here. So that's why I came from here. I just get started from here. Afferent arteriole, the smooth muscles of the afferent arteriole are called as juxtaglomerular cells. Cuboidal epithelial cells of the distal convoluted tubule are called as macula densa. Okay, so macula densa and juxtaglomerular cells are collectively called as JG apparatus. That means if you see here, that if I want to show here, this is the cuboidal epithelial cells, and these are said to be that smooth muscles of the afferent arteriole. This particular box is said to be juxtaglomerular apparatus. When you go back, you can see here also that cuboidal epithelial cells of the distal convoluted tubule and the smooth muscles of the afferent arteriole is called juxtaglomerular apparatus. Understanding these lines is very important here, that I hope when you go to the textbook even you can understand this if we learn in this particular way where I am saying what I am saying. Okay, so this is a juxtaglomerular apparatus. Let me go. This is the juxtaglomerular apparatus. This is DCT and this is afferent arteriole. Little bit more in zoom, we have observed here that smooth muscles of the afferent arteriole and cuboidal epithelial cells of the distal convoluted tubule are said to be macula densa. The smooth muscles of the afferent arteriole are called as juxtaglomerular cells, and juxtaglomerular cells, macula densa, collectively called as juxtaglomerular apparatus. Okay, what they do actually? What they do, that we need to write all that particular. Juxtaglomerular cells are going to secrete renin, the renin. So all the participants will take it out once, and then after we enter into the topic Raas mechanism, renin angiotensin aldosterone mechanism. We used to say, so juxtaglomerular cells are going to secrete renin enzyme. Then angiotensinogen is secreted from liver. Angiotensinogen is from liver. Angiotensin converting enzyme. Angiotensin converting enzyme. ACE, we say. Angiotensin converting enzyme from lungs. Okay, so angiotensin converting enzyme is from lungs. Juxtaglomerular cell secrete renin. Angiotensinogen from liver. Next, ADH, antidiuretic hormone. Also we say vasopressin. Where do you get vasopressin here? The neurohypophysis of the pituitary gland. The neurohypophysis of the pituitary gland is going to secrete that angiotensin. The pituitary gland is having two portions, adenohypophysis and neurohypophysis, that we'll discuss in chemical control and coordination chapter. Till the time, you just remember this. ADH or vasopressin is from the neurohypophysis of pituitary gland. Okay. Next, the one more hormone, aldosterone. The aldosterone is from adrenal cortex. Adrenal gland is having two portions, that cortex and medulla. The cortex portion of the adrenal gland is going to secrete a hormone called aldosterone. Okay, what these are all doing actually? Raas mechanism. What is Raas mechanism? We'll see. First of all, let's take a look on these. Juxtaglomerular cells are going to secrete renin. Angiotensinogen is from the liver. Angiotensin converting enzyme from the lungs. ADH or antidiuretic hormone and vasopressin we say, that is from the neurohypophysis of the pituitary gland. Aldosterone from the cortex of the adrenal gland. All these are participating in the Raas mechanism. All these are participating in Raas mechanism. So what is Raas mechanism? What is the requirement of the Raas mechanism? What is Raas? Simply we say renin angiotensin aldosterone system. Renin angiotensin aldosterone system. For that, we'll create a situation here. First of all, imagine a person, a human, that not drinking water. That means for a long period, that we create all extreme conditions. It is the summer. It is summer. That not drinking water. Okay, drinking water means no, water is not available. Not drinking water. Then he is in the desert. Not availability. There is no availability of the water. So in this condition, what kind of changes will come in the body? What is the basic requirement we say when we are not drinking water? We are not when we are not drinking water, that the body is the concentration of the blood is going to be increased. Do you accept this? Colloidal nature of the blood is going to be increased. Okay, so the blood colloidal nature, that means blood in our language, normal language, we say blood will become syrup, thick from Sprite to pulpy orange, it will change, isn't it? So that means in this condition, it's a summer, not drinking water, it's in desert condition, that a lot of water is going in the form of sweating. In this condition, a Raas mechanism will come first. Okay, Raas mechanism, renin, angiotensin, aldosterone mechanism. Who will respond for this? So in this particular situations, that the blood comparatively, the blood pressure will decrease. If I say, do you accept that blood colloidal nature increases when blood is becoming more thicker? So what can be expected here? The blood pressure will decrease. The decreased blood pressure recognized by these certain places where we say, like liver recognizes, then they secrete angiotensinogen. The liver recognizes and gives angiotensinogen is secreted from the liver. And for this, you people need to remember the liver is so far to the kidney. How it happens that you know that cardiac output for 1 minute, the blood is rotating all over the body, isn't it? So that's these kind of silly doubts you should not get over. Okay, angiotensinogen released from the liver will be converted into angiotensin 1. Will be converted into angiotensin 1. Okay, so who converts that particular angiotensin 1? Angiotensinogen from the liver is converted as angiotensin 1 by renin. Renin, do you know renin? Who is renin? It is from the juxtaglomerular cell. Then angiotensin 1 is converted into angiotensin 2 with the help of angiotensin converting enzyme. So what do you want exactly at this time? Angiotensin 2. So angiotensin 2 is formed from the angiotensin 1 by angiotensin converting enzyme. Okay, when it comes to the text, we have some the great confusion. People use it to say like this: angiotensinogen from the liver is converted into angiotensin 1 by renin, which is from the juxtaglomerular cell. Angiotensin 1 is converted into angiotensin 2 by angiotensin converting enzyme of the lungs. Likewise, they said. That's why I made some separation. I already introduced this particular to you. Juxtaglomerular cells are going to secrete renin. Angiotensinogen is from the liver. Angiotensin converting enzyme from the lungs. And the more hormones are coming, ADH or vasopressin from the neurohypophysis of the pituitary gland. And aldosterone, the adrenal gland. Aldosterone, the cortex of the adrenal gland is from the cortex of the adrenal gland, there is an aldosterone. So all this, with all this, we just managed to happen to form angiotensin 2. Simply now I can say angiotensinogen is converted into angiotensin 1 by renin. Angiotensin 1 is converted into angiotensin 2 by angiotensin converting enzyme. Okay, what angiotensin 2 do? That what is the problem actually? The problem is that the person is not drinking water for a long period of time, that water levels in the body is dropped down, the blood pressure decreases, isn't it? The blood pressure decreases. So this is the problem, blood pressure decreases. So how we manage this is the problem. Okay, so blood pressure decrease. So for that, the vasoconstriction occurs. For that, the vasoconstriction occurs. Okay, so this vasoconstriction, that means here what is vasoconstriction? When the blood vessel is in certain diameter, they are going. I request the people to unmute themselves. Who is coming? Shravya. Okay, so the vasoconstriction occurs. That means if it is going like this, so when we do reduce this particular diameter of the blood vessel, then definitely this problem can be solved over. The blood pressure who is decreased can be increased by vasoconstriction. Okay. What other functions of the angiotensin II? What is the problem? We are not drinking water, isn't it? That creates thirsty condition. That means here in this particular area, in the particular esophagus, the thirsty condition. That means that particular area, the mucus cells are not going to secrete the mucus. We feel dryness in this particular area, the esophagus, the pharynx to esophagus area. So that thirsty condition will be created over that will we feel the thirst about that particular drinking. If you remember that hypothalamus is going to play this particular role. Angiotensin stimulates the hypothalamus. And this much wide is not there, but we are learning. Next, what are the other functions of the angiotensin II? We know in the DCT, distal convoluted tubule, the absorption of the water is possible with the help of a hormone called ADH, or also we say vasopressin. So, angiotensin II stimulate the secretion of the vasopressin, that what do you call this kind of absorption of water in DCT? Facultative water reabsorption. That facultative water reabsorption. It promotes the facultative water reabsorption. Okay. Then the other function, that one more, that we know if you want water, that you need to maintain the hypertonic condition, isn't it? You need to maintain hypertonic condition. That means that makes the absorption of salts. Aldosterone is the hormone helpful for the absorption of salts. So angiotensin II promotes the secretion of the aldosterone hormone from the adrenal cortex that make the absorption of salts. So let's see functions of the angiotensin II. What are the functions? The problem is blood pressure decrease. That is solved in the form of the vasoconstriction. That blood vessel gets reduced in the size, that increases the pressure. Meanwhile, it creates the thirsty situation to drink water, and it promotes the secretion of the ADH or vasopressin for the facultative water reabsorption in the distal convoluted tubule and initial collecting duct, and it promotes the secretion of hormone aldosterone. That angiotensin II promotes the secretion of hormone aldosterone. Okay, so these are all the functions here. These are all the functions which that our problem will be reduced. Renin angiotensin aldosterone system. We say this as renin angiotensin aldosterone system. Okay, we'll make some contrast issue for this. That means, for example, that you taken lot of water. When you drink lot of water, what happens when you drink lot of water? That is not we are not going in the sweating, where the sweating is not happening. That means, well, let's create the situation here. It's a winter season. That when you drink a lot of water at a time, 1 liter or 2 liter of water. So what happens to the blood? Blood, that more it is getting diluted over, isn't it? When blood is more diluted, the blood pressure increases, isn't it? The problem will come here, blood pressure increases. The contrast to the Raas mechanism we are talking about. The contrast. When blood pressure increases, when you drink a lot of water, it's a winter season, there's no sweating here, no water loss from outside. So that how this problem can be solved over. Blood pressure increase. How this problem can be solved over. Atrial natriuretic factor. For that, we are using the atrial natriuretic factor, which is released from the right atrium of the heart. Atrial natriuretic factor from the right atrium of heart. That means the increased blood pressure recognized by the heart. So that brings atrial natriuretic factor for secretion. What atrial natriuretic factor do? What is the problem? Blood pressure increase, isn't it? So blood pressure can be that if this is the blood vessel, then the normal way the blood pressure is increased in this particular blood vessel. Vasodilation occurs. That means the blood vessel size diameter is increased. So automatically the blood pressure will be decreased. So that problem is solved. Vasodilation. That blood pressure reduced over because of vasodilation. What's another thing? We should not absorb water, isn't it? Then inhibit the secretion of the required things like ADH, aldosterone, we should inhibit. That means simply we say it inhibit Raas mechanism. It inhibit, simply we call Raas mechanism is getting inhibited. Okay. So the two contrast situations we discussed today, the two contrast situations, or we can say the two complicated situations even. So what are the two contrast situations here? The first one that it's a drug that the availability of the water we are talking about, less availability of the water, not drinking water, blood became thick, blood pressure decreased. So these are all the examples we took for. Some are not drinking water, desert condition. So is that anything, anytime it can be happened over, but I created a situation. If we are in the desert, when that's a midsummer in the afternoon, barefoot, you are walking on the desert, so that no availability of the water. So what kind of mechanism will come forward? This mechanism, Raas mechanism, we see that renin angiotensin aldosterone system will be activated in the body. That angiotensinogen is converted into angiotensin 1, and angiotensin 1 is converted into angiotensin 2. Conversion of the angiotensinogen into angiotensin 1 is possible by renin. Conversion of the angiotensin 1 into angiotensin 2 is possible by angiotensin converting enzyme. So what angiotensin to do? That the problem blood pressure is decreased due to such condition, that it helpful for the constriction, that reduce the blood vessel size, that makes the pressure will be increased over and create the thirsty situation, and the stimulate the secretion of the ADH or vasopressin for the facultative water reabsorption in the distal convoluted tubule. Then we stimulate the aldosterone for the more absorption of the salts here, that more absorption of salts promote more absorption of water, that we learn in counterflow. This is called Raas mechanism. What is the contrast situation here when you drink a lot of water? When you drink a lot of water, if now in this particular situation, that where the outside atmosphere is little bit cool, if you drink at a time 1 liter water, you may feel within half an hour, you may feel that the sensation of urination, isn't it? That means the bladder is filled. How it is filled? How it filled? So that consequences, suppose we are taken 1 liter water at a time in this particular situation, the cool atmosphere outside, no water is going in the form of sweating. So at this time, your blood pressure will increase immediately. The blood pressure that increases because of dilution of the water into the blood. So then, now it recognized by the right atrium of the heart that atrial natriuretic peptide, atrial natriuretic factor is getting liberated over. That particular atrial natriuretic factor is what it is doing. First of all, immediately it makes the dilation of the water, vasodilation. It creates vasodilation. That vasodilation, the blood pressure will be reduced. The blood pressure will be reduced, and it also do the inhibit the secretion of ADH or aldosterone mechanism. That the ADH or aldosterone mechanism will happen that inhibit the secretion of the ADH and aldosterone. What do you call? Simply we say that inhibit Raas mechanism. That inhibit the Raas mechanism. Okay, so this is that renin angiotensin aldosterone mechanism we say. Okay. So for that, let me, all the participants here will get match the following question from this particular area. What are all the participants? Let's take both Raas mechanism and that ANF mechanism, atrial natriuretic mechanism. We'll take a glance look of all of them back again. All of them back again. First of all, we need to begin from the renin. The renin from juxtaglomerular cells, isn't it? The renin is from juxtaglomerular cell. Next, angiotensinogen. This is a math the following, a very frequent and regular math the following question. Angiotensinogen is from liver. Angiotensin converting enzyme is from lungs. Angiotensin converting enzyme is from lungs. ADH or vasopressin is from that neurohypophysis of the pituitary gland. It is from the neurohypophysis of pituitary gland. Okay. Aldosterone. That one more participant is aldosterone. Adrenal cortex. It is from the cortex portion of the adrenal gland. Next, what the more other people participated there, that ANF, atrial natriuretic factor. Atrial natriuretic factor from the heart. Atrial natriuretic factor is released from the heart. Okay, so these are all the different issues, different parts here. This is a very regular and frequent math the following question. Okay, so this is the angiotensin Raas mechanism. We say renin angiotensin aldosterone mechanism. This particular to learn this particular mechanism, we need to go for juxtaglomerular apparatus. Actually, juxtaglomerular apparatus information is not available in the Ncert text here. Just I mentioned the name. Our state text is having the enough good representation of the juxtaglomerular apparatus. Okay. Then let me take a look here that because this is a little bit complicated item, I am repeating the juxtaglomerular apparatus again for you. That particular juxtaglomerular apparatus, the afferent arteriole, the connection between the afferent arteriole and the distal convoluted tubule. The participants here, the afferent arteriole from the blood vascular system, DCT from the nephron. These are the participants. When you see little bit, when you zoom that area, you can see like this, that they are densely packed cells of cuboidal cells of the distal convoluted tubule and smooth muscles of the afferent arteriole. What do you call the smooth muscle cells of smooth muscle fibers of the afferent arteriole as juxtaglomerular cells. The densely packed cuboidal epithelial cells of the distal convoluted tubule are called as macula densa. So the macula densa and juxtaglomerular cells are called juxtaglomerular apparatus. Okay, let's take in text language. Juxtaglomerular apparatus include the juxtaglomerular cells, who are the modified smooth muscle fibers of the afferent arteriole, and the macula densa, who is the densely packed cuboidal epithelial cells of the distal convoluted tubule, which come in contact with the afferent arteriole. Likewise, this kind of statement you will find in the text here. Without this particular picture, you can't understand anything here. If possible, take a screenshot of this. So that particular area, the juxtaglomerular apparatus, this is a complicated one. And the one more thing to be remembered in this particular area, the final issues here, the final issue that we made a math the following, the renin, juxtaglomerular cells, it is from, then angiotensinogen from liver, angiotensin converting enzyme from lungs, ADH, antidiuretic hormone or vasopressin from the neurohypophysis of the pituitary gland. Aldosterone is from the adrenal cortex. And finally, atrial natriuretic factor. Atrial natriuretic factor is from the heart. Okay. So the two situations and two functions. Let's take it out. Let's take it out. First function. What is the function of Raas mechanism? Angiotensin II. This one we are talking. Angiotensin II. At the time that blood pressure is decreased, that problem is solved by vasoconstriction and creating the thirsty situation and stimulating the ADH or vasopressin for the facultative water reabsorption in the distal convoluted tubule and collecting that, and stimulate the secretion of the aldosterone from the adrenal cortex for the absorption of more salts, which facilitate the absorption of water. This is called Raas mechanism. Then the problem when you drink a lot of water, when water levels are increased in the blood, when blood become more diluted, at the time what happens? So talking about the atrial natriuretic factor that released from the right atrium of the heart, atrial natriuretic factor, which is released from the right atrium of the heart. So what it do? The problem at present is blood pressure is increased, isn't it? The problem will be solved by vasodilation. By increasing the diameter of the blood vessel, the blood pressure automatically come in control, they will be reduced over, and it inhibits the secretion of the ADH and aldosterone, which is facilitating the absorption of water. At present, there is no requirement of the absorption of water. So that's why they inhibit secretion of ADH and aldosterone. That means simply we say they inhibit facultative water reabsorption in the DCT. That's what we said, that as facultative. Whenever necessity comes only, we absorb the water in DCT and initial collecting duct. We call such kind of absorption is facultative water reabsorption based on the requirement and based on the necessity. In this case, no necessity. No necessity means no requirement of the ADH and aldosterone. That's why ANF is going to inhibit the action of ADH and aldosterone. So these are the complicated part of this particular area. So let me conclude this by giving this again. The renin from juxtaglomerular cell, angiotensinogen from liver, angiotensin converting enzyme from lungs, ADH, neurohypophysis, ADH from the neurohypophysis of the pituitary gland. Then aldosterone is from the adrenal cortex. That finally, that ANF, atrial natriuretic factor, is from the heart. Okay. So this is the condition, this is the situation here.